So, for example, let's look at this example, this question. You are provided with solid Q. So, solid Q, we are required to dissolve it in 10 cubic centimeters of distilled water. So, dissolve a portion of the solid in 10 cubic centimeters of distilled water. So we'll measure 10 cubic centimeters of distilled water. Then we take a portion of the solid provided. So we can measure it using a spatula. We can just put a portion of it using a spatula. Then we put in a 10 cubic centimeter of distilled water. After that, we shake until it dissolves. So we expect this solid to dissolve. So anytime we are doing chemistry practical, we are doing it knowing what should happen. Yeah, so that if what we expect to happen has not happened, we say it has not happened the way we expected. So in paper 3, we just have to read and we have prior knowledge to what we are going to do. So that when we are doing it, we know what should happen. If what should happen has not happened, we say that it has not happened. For example, when I'm doing this experiment, I'm given solid Q to dissolve in distilled water. I'm expecting solid Q to dissolve in distilled water. So, and I'm also expecting it to dissolve to form either a colorless solution or a colored solution. So, if it dissolves to form a colorless solution, then these are my inferences. According to this result, it dissolves to form a colorless solution. The table here is divided into two parts, observation part and inference part. Inference is like conclusion from what we have seen from the result from the experiment, which is observation. So my observation after dissolving solid Q in about 10 cubic centimeters of distilled water is it dissolves. You see, I've said whether it dissolves or it is insoluble. According to the result from this experiment, solid Q is soluble in water. So I say it dissolves in water to form a colorless solution. You see, I'm mentioning the color of the solution. This side is 1 mark. If you state whether the solution is soluble or insoluble, you get half a mark. And then when you mention the color of the solution, you get another half a mark. So that one will earn you a total of 1 mark. But if you just state that it dissolves, then you will only earn half a mark. And sometimes you will not get anything on the inference side because you have not stated the color of the solution. If you state well the solid is soluble, but you have not stated the color of the solution formed, you may not score. Because how can you score yet you have not stated whether the color is colorless or colored? So if it is colored, we state the 3 colored ions that are absent. Because if they were there, the solution would be colored. So according to this result, copper 2 ion, iron 2 ion, or iron 3 ions are all absent in that solution. And that's why the solution is colorless. But if our inference is like this, it dissolves to form a blue solution. A blue solution. It dissolves to form a blue solution. Our inference will be copper 2 ion present. You see, it dissolves to form a blue solution. The inference will be copper 2 ion present. And if the observation is dissolves. It dissolves to form a green solution. A green solution. Then our inference will be ion 2, ion present. Our inference will be ion 2, ion present. And lastly, if our observation is it dissolves to form a brown solution, then our inference will be ion 3, ion present. Ion 3, ion present. Ion 3, ion present. So that is all about testing for solubility. So we cannot mention all the colored ions when the solution is colorless because there are so many colored ions. So this is a place where you are allowed to write a negative inference because there are only 3 colored ions: copper ion, ion 2 ion, and ion 3 ion. So we are allowed to state that they are all absent when the solution is colorless. But when the solution is colored, then we state the specific ion according to the color of the solution as from the observation. But when it is colorless, we state the 3 ions, but we don't state all the colored ions. There are over 20 colored ions, and we cannot state them here. So this is the only place that we are allowed to state that we give inference in a negative way, absent. But in paper 3, in most cases, we always like to give inferences in positive inferences. Present, 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 present. But there are some instances where we are forced to give negative inference, absent. So that is all about the test for solubility in paper 3 when we are testing for cations. Yes, so we cannot give inference for anions because there is no colored anion. So all the cations are tested in solubility. So, and if you are given, you are testing for organic compound, and you are told to dissolve a certain solid, and it dissolves to form a colorless solution, we don't talk about colored ions because we are now dealing with organic compounds. So in organic compounds, we are allowed to state whether the solid is polar or non-polar. So a polar compound, if it's organic compound, must dissolve in water. Non-polar compounds are insoluble in water. So a polar compound will always dissolve because a polar compound is a compound or a substance with both partially negatively charged pole and a partially negatively charged pole. So these two opposite charges, they get attracted to polar water molecules and they dissolve in that water. So all ionic compounds, most of them are soluble in water because they are polar. While compounds that are not ionic, they are non-polar. And then we have also some solid liquids that are polar molecules that are also soluble in water. For example, we have alkanols, alkanoic acid. They have hydrogen bonds that make them soluble in water to form a given type of solution. So next one, we want to focus on colorless ions.